do payments real quick and we'll get started. Today the 12th. Jaden, he's not here either. Yes. All right, there's attendance. All right, I know break sometimes makes you tired. Get a taste of the good life. All right. Okay, guys, so we've got 3 more chapters. I'll say this again. We've got 3 more chapters, 8, 10, and 12. So chapter 8 is our consumer math. So we're just going to do like review math today, but then 8.1 and 8.3 is just review stuff, really stuff that we've covered to a degree. We'll go a little bit further. But when we do the next section, so on Wednesday, we'll do the math that you use to buy a house or buy a car. So that's what's coming on Wednesday, because that is something that everybody needs to be familiar with. I'll share this with you right now. My mom is looking for a new used car. And I don't know if many of you have bought cars before on your own, but if you go to a dealership, they will work it out so that you can have the car payment that you would like to have, but the terms of the loan may change. The interest rate could rise or lower, but the more likely to happen, the length of the loan will get longer or shorter. So she did come by the house, because I just begged, please don't sign on the dotted line until you let me check the math. And so she came by my house and she was showing me, and I said, do you understand that they have you paying for a used car for 6 years? She was like, did not realize that. She said, I said, this 72? That's your clue. And she said, well, I asked her about that 72, and she told me that it was like $333.72. And I said, well, it's not. She just didn't want to tell you what was happening. And I said, if you look at this one, when they did the math, they did this payment for 60 months. I said, you don't want to pay that long for a used car. It may not even still be working. Hopefully it will be. But when you buy a used car, you don't know what you're getting. So you have to make sure that you have some money for whatever goes wrong. So anyway, so we're in the throes of that. Every time she buys something, stresses me out. But she's good at math, but she doesn't trouble herself to do it. I mean, there's even an app for that, you know? I mean, you could download an app and do that. I always tell students, when you get ready to use an app, make sure that the app is calculating the math correctly, because we have like a mortgage project, and we'll do that. We'll actually go through the steps of buying a house. And so I really don't care if you use an app, but you need to use the formula I give you to make sure that the app is calculating correctly. If it's not calculating correctly, you're going to get the wrong numbers on your project. If you and they do that. There's a lot of apps out there, and some of them do have the wrong numbers. They get close. They get you in the ballpark. So that's pretty good. But I want you to be able to do it yourself, because it's not a difficult formula. Now the monthly payment one, it's kind of a pain formula. It's not hard, but it's like a lot of parentheses to get in your calculator. And so it gets a little congested, but there is a formula and you can use it once to see if, your app is working well, so that because that's how I check your work. I have it programmed into an Excel sheet because I got tired of punching them in. Anyway, so I made myself an Excel sheet to grade it. Anyway, but that's when we get ready to buy a house. It's a big deal. So what we're going to do today is just basic interest stuff. We did this in chapter 5, and then simple interest. Simple interest is really not important in today's world. Simple interest you might pay if you're dealing with a loan shark, which I hope you're not, or I don't know, maybe a pawn shop, maybe these days, maybe if you borrowed money from someone in your family, they might do simple interest. Simple interest is just when they charge you interest one time, and that's it. That's not where we live, because that's not how you make money. We live in a world of compounded interest, where they compound it like every month, or worse, every week or every day. I mean, where it compounds more often, and then they earn more interest on your money. But it also works for you. Sometimes it does. When the economy is bad, the interest rates will go down, right? So to spur the economy into being good, right? Because if the interest rates are low, you'll spend money, like on mortgages and stuff like that. And the only deal with that is when mortgage rates go down, what happens to house prices? Yeah, I mean, I don't know. I know y'all probably aren't looking at houses and stuff, but house prices are way up. And then when the interest rates go back up, then the prices of the houses will come down, but you just can't have it both ways. So the biggest thing that I can suggest, and we'll talk more about this when we do this section Wednesday, is start saving money for that down payment. So at least there's some fees and monies that you can come out. I'll give you advice on that as you go. Just because I'm a math major. I didn't major in education. I am a math computer science major. That was my major at Wofford. And I went through high school and I went through college, and I never had any information other than the formula for, compound interest for buying a house. I didn't have all that extra information, but thankfully by the time I bought a house, there was the internet, and I was able to figure out what I needed to know ahead of time. But I want you to know ahead of time, even if you've got a house and you're refinancing, I just want you to have the information. But today, not buying houses, not buying cars, not buying boats. And I'm just going to go on record right now for saying finance as few things as you possibly can. Just saying. We'll talk about that later too. All right, let's just go through the review stuff really quickly. All right, hold on. Let me turn this so I can see my people at home. Oh, I've got what? 1, 2, 3, 4, 5, 6, 7. I've only got 7 people on Zoom. You see this? And then we've got 1, 2, 3, 4, 5 people here. That's 12 people. You know how many people are in this class? 22. Where's our people? You know how you felt this morning when you woke up? Yeah, me too. That's what happened to them. Go y'all. You made it in. Because I know, I felt it too. And my daughter, I was like, you were going to make me late for work. You happy about it? All right, there's Jaden coming in late, sleeping in while we didn't get to. What's he thinking? All right, so let's go ahead and let's just review through this stuff really quickly. Do you remember? Percents are part of 100, because we talked about slope and the slew to grade, and how if it's 6%, that means 6 over 100, and that's its vertical change over its horizontal change. Talked about that. And we talked about that in chapter 7, so that was more recently than chapter 5. But in chapter 5, we said if you want to take a percent into a decimal, how many places do you move the decimal? Yeah, 2. It's always 2 places, regardless of how many numbers are there. So if it's 75%, 5%, that's 0.75. If it's 5%, how do I write that as a decimal? Yeah, that's the one I told you people will just brain malfunction and put 0.5 on, and then it's 50%. And if it's 375%, yeah, so only two places to go to decimal form, always, no matter how many numbers are there, just two places. 375%, that's like a jewelry store or, I don't know, pizza. They say those things have really, really big markups. And you know jewelry has to have a big markup because if you go out and buy a $3,000 diamond engagement ring, and then you're engaged 2 years later and you've decided, you know, I just can't stand this person, not for a lifetime. Well, how much did we pay for the engagement ring? I already forgot what I said. $3,000. Okay, that's a nice one. That's a nice one. Okay, so you've got $3,000 into this ring. How much are you going to get for it once you break up? If you're lucky, right? It's crazy. I mean, it's crazy. So you know the markup must be huge because you certainly, so there's my next advice. When you get ready to propose, go shop at the pawn shop. All right, so now we go the other direction if we're going from decimal per 2%. So if you're trying to find a rate, you're going to move it to the right. Okay, I didn't put direction, did I? I'll do that. And that we did in chapter 5, so it's not new, but it has been a while since chapter 5 now. Okay. All right, now we have calculators, so this next part is going to be even easier. So if I want to change a fraction to a decimal, I can use my calculator to knock that out. If I dig it out of my bag. All right, well, the first one we could do in our head. So a 3/4 would just be 0.75, and that would be 75%. Let's see, 3 divided by 8. So that's 0.375, so that is 37.5%. And then 17 divided by 80, 0.2125, so that would be 21.25%. Do y'all remember, did I open your chapter 9 test so you could look at them? No, nobody's looked because you didn't want to do that over the weekend? I'll double check it because I'm just sitting here thinking, I think I did, but I'm not positive. Okay, so then let me remind you of this. If you're going decimals to fractions, there's our places right there. You just look at the last place. And your calculator will do a lot of conversions for you. Did I show y'all how to do this on your calculator? Okay. Well, I'll do it by hand, but then I'll show you how to do it in your calculator because, you know, it's there now, right? All right, so remember tenths, hundredths, thousandths. So you look at the last place, thousandths. And that would be 25 over 1,000. So I'm going to let my calculator reduce this for me. And that would be 1 over 40. Okay, so if you put that in your calculator, 0.025, you've got a button on there. You've got a couple of buttons. On the gray and white one, you have this button that's down on the bottom right, and that will turn it into a fraction, I believe. And you also have a button somewhere on that calculator, and this may be on other calculators as well, that has F to D. It may be a regular function, it may be a second function, and it will do that for you. So take a look on your calculator. If you don't see it, I can come look. To make sure you got it. All right, if you've got a TI graphing calculator, you put it in 0.025. All right, let me hold this up here. So if you're doing it on this one, and then you've got a key that says math right up here. And then the top thing says fraction. And so you hit enter and then enter again, and it will convert it to a fraction. And if you've got questions on how to do it, you can Google it or ask me. Okay. All right, so let's go ahead and finish this out then. So that's going to be 8/10, which will be 4/5. This will be 3 over what? 100. And 7 over 1,000. I mean, so it's not hard to do. It's just that some are hard to do, you know, and so some of them are hard to do because of all the reducing, and that's when your calculator is super helpful. Okay. All right. So let's actually work some percent problems. Now, there's a couple of different ways to do it. You can do it this way. Is equals percent times of. That's basically what this is. Is equals percent times of. Okay. So that is the way that I will work most of my problems, but you might have learned is over of equals percent over 100. And then cross multiply also works. You'll get the same answers. So no problem there. You can do whichever way you like. Okay, so let's just do a couple of problems. So this is straight up basic interest. We'll crank it up in a minute. All right, so if I say find 5% of 60, that's my of number. So the one that I don't have is the is number, right? So that is my is number equals 5%. You have to put this in as a decimal. So that would be 0.05 times 60. Using that formula, that would give me my is number. Yes, thank you. So your is number is 3. So 5% of 60 is 3. That's what we just did. All right. This one says what is again. Excuse me. So I'm not going to do that one because it's the exact same thing. Let's move down to a different one. Let's move down to this one right here. 3. All right, so this one says 6 is. So that means this is my is number. There's my percent. And I don't know my of number. So that's not a 0.6. That's where I dotted my I. I better fix that before I confuse somebody. Okay. All right, so 6 is 12% as a decimal. What number? We don't know the number, so we just put X. So now we go to our solving equation skills. How do I solve for X? Yeah, don't scare me like that. Okay. So 6 divided by 0.12. So you've got 50. So 6 is 12% of 50. And then we'll do 4 where we're missing the percent. So there's my is number. We're looking for the percent, and there's my of number. So 13.5 is what percent of 90? Again, we're just dividing, just get that P by itself. But now this one might be a little bit tricky just because of the end. I don't know, maybe not. So 13.5 divided by 90, and I get 0.15. Now that is my percent as a decimal, not as a percentage. So if I say, what is the percentage, what would you tell me? Yes. All right, so 13.5 is 15% of 90. Yes? It's basic algebra, right? All right, let's keep going. Let's go shopping. All right. Now, I do suggest that when you're doing some shopping, that you, especially if you're self shopping. Now, I know men are not so sensitive to this, and that's, primarily what we have here. But your wives want you to be sensitive because the more money you save, the more that they can shop. Okay, I'm just saying. It matters. Okay, you can only spend it once, right? I know it took me a while to get my husband to be money sensitive. I would do coupons and I would save and I would look for stuff on sale and he would just go buy what he wanted. And he's grown out of that now. He will look for a coupon or wait for a sale. But here's the thing. If you go somewhere to a store, if you go to Academy and they say, these Nike shoes are 25% off today. And you go to the register, if you don't have an idea of what you should be paying, then they could give you 15% off. And if you're not paying attention, that's just what they do. No, they're not trying to cheat you at Academy, but they're not doing the math for you. Whatever scans up into the computer is what you pay, right? I mean, that teller is not going to be like, oh, you didn't get your whole discount. Let me fix that for you. Because cashier, that cashier is just going to scan it and tell you what the computer says to pay, right? Because that is their job. They're not making the big bucks, and so they are not going to do the math for you. So if you're getting 25% off something, you need to know what you should be expecting to pay when you get to the register. Yes? Okay, so you notice a lot of times, everybody's walking around with a calculator on the phone, right? So a lot of times if you shop at Kohl's, and man, I know you don't shop at Kohl's, but other places probably do this as well, they will have a percentage off and then you get an extra percentage off. All right, well, if this rack is 20% off and I have a coupon for an extra 30% off, does that mean I'm getting 50% off? No. That's kind of what they want you to think. That's one of those things shopping. I'll hear people talking and they'll be like, well, it's 20% off and you got that coupon for 30, you got 50% off. And I'm like, no. But they don't want a math lesson right there in the store. So I do not give them one. But I want to, y'all. I want to be like, no, it's not 50% off. That's the trick they're playing on you to get you to shop for. Anyway, the 20% comes off the top, which lowers the price, right? And then once the price is lowered, then they take the extra percentage off so that you're getting less. That's still not bad because you're probably getting somewhere in the market of 44% off, but it's not 50% off, and that's what people assume. And then they get to the register and they're not good enough at math or they're too lazy to do it to know what they're supposed to pay anyway. Anyway, but we all have a calculator, but the problem is when you learn this in elementary school, they taught you the two-step way, and we're going to do it shorter so that you wouldn't have to spend a bunch of time on your calculator. All right, so take a look. All right, so this is what you learned. All right, we're getting a computer, a nice one apparently, for $2,150. And the tax is 6%. Well, it's gone up to 7% now. All right, so you would multiply by 6%. There's your tax rate. So you would say 2150 times 0.06, and that's $129. That's going to be your tax. So how much am I going to have to pay for that computer to get out the door with it? Or what am I going to have to do to figure that out? You don't have to tell me the number. Right. So I've got to add the tax on. Now this is really a big deal. Like my son, he has 2 checking accounts. One he uses for a savings account because you get free checking, but you don't get free savings. So we just got 2 checkings account because the interest rate is not good enough for it to matter right now. And then what he does is when he gets ready to buy something, he'll take money and switch it from the savings account over to the checking, which stresses me out a little bit because he never keeps hardly any money in that checking account. But his fear is he's going to lose that card because I think he keeps it sticking in the back of his phone. I don't know. So he's worried he's going to lose it. And if he loses it, there won't be any money in that account, the debit account, for anybody to get. So that's his plan, and I like that, but I always feel like something's gonna bounce. So if he's ready to buy something, like if he were buying this computer, he would not be buying this computer, this is outrageous. But if he were buying this computer at the store, he would calculate up how much it's gonna cost, and he would transfer that amount over, and then he would go check out. Stresses me out. But what if it doesn't clear? I don't know. It moves pretty quickly, but not always. So I just want to show you how to do it in one step, okay? All right, if you're paying $21.50 and tax is 6%, and you just are punching it into your phone and you want to know how much you got to pay to get out the door, just multiply it by 1.06. So notice what's different. I just added in a 1. The 1 is going to pull in the $21.50, and then the 0.06 is going to tack on the sales tax. So if I say $21.50 times 1.06 should equal $22.79, and it does. And that's one step. And you wouldn't mind doing one step on your calculator. You don't want to have to remember a bunch of numbers. I don't either. So, and that works for discounts too. I'll show you in a minute. Okay, so take a look at this next one. We're buying a Beats pill, and it's $189. They've come way down from that. Not way down, but they've come down. All right, so we want to see how much it's gonna cost us to get out the door in one step. So I've got $189. What am I gonna multiply by? 1.08. 189 times 1.08. So $204.12. Okay, what if we did that? So now we know that's what's gonna, that's price plus tax. All right, what if I said now, okay, how much tax did you end up paying? What would you do? How much tax did you pay? Because you just did that in one step.
Subtract the difference of 204.12.
Good kid. Okay, so tax would be 204 minus the cost of the Beats pill, which was $15.12 tax. So you can still figure out how much the tax is, even if you do it in that one step. But let's face it, if you're shopping, you just want to know how much you're going to pay. Or in my son's scenario, he needs to know how much he's got to transfer, so so everything gets covered. All right, so let me show you how to do it on a discount. I'm sorry. I was looking to see, I was thinking this was a short section. I talk a lot in this chapter. Sorry, y'all, I'll try to back it up. Okay, so here we go, we're shopping. Let's do it the way that you learned it in elementary school. You would say, I've got $150 worth of stuff and a coupon for 25%. So we make that decimal form. I think that's $37.50, but let me make sure. Yeah. So $37.50 is my discount amount. So now I'm going to say 150 minus my discount amount, which is what, 112.50. So that's before tax, right? 112.50. That's what it should ring up to before tax when I go to the register. Now, if something does ring up wrong and you go to the register and you say, hey, that was those Nikes were supposed to be 25% off. I didn't get 25% off. Will they argue with you? They won't. They'll fix it, won't they? They'll fix it. And so there's nothing to be lost by making sure that you're getting your full discount. It happens way more than you think. I only say that because the numbers in my head happen easily. And so I always know what I'm going to pay when I'm getting ready to go to the front. And if it's not right and I say something, they go back, they look, they change it, I'm good out the door. I say, thank you very much for helping me out with that, and have a great day. But I'm not going to pay too much, okay? Again, they're just scanning it. It's not their fault if it rings up wrong, right? They're just scanning it. Okay, So if you want to do that in one step, take a look. All right, now what percentage is our discount, guys? It's 25%. So that means that's 25% that you don't have to pay, right? So what percentage are you having to pay? 25% off,
off.
75%. So just skip this middleman here. I mean, here we multiply by got the discount, and then subtract the discount from the amount we've got to pay. But if we're not paying 25%, that means we're paying 75%, right? So look, guess what this is going to be when you multiply it? You don't have to guess hard because it's up here. One step. And I think the multiple steps is why people don't check stuff. Because you have to remember what number you had the first time. Or figure out how to use those memory buttons, which only work half the time. Anyway, so if the sale is just 10% off, what am I multiplying by? 90%, so 0.9, right? You know, if it's 80% off, what am I multiplying by? No, if it's 80% off.
80% off by
0.2. Okay, yeah. And don't even buy that because it's probably broken. Yeah. Okay. So then even if you wanted, like, so if this were my son and he were shopping and he needed to transfer the money and tax was 7%, now he could take this in his calculator and say times 1.07 and know what it was with tax on it. Okay. All right. So 25% off means you are paying 75% of the cost, of the original cost. Let me write that down so you'll know what, if you look back at that, what we were thinking. All right, so let's just do this one before we go. 769, some sort of specialized bike. It's 30% off times 0.7. So $538.30 before tax. So 30% off means we are paying 70%. It's easier, right? It's more applicable. It's something you could use easier. Again, guys, if you don't buy things on sale, it's useless. Buy things on sale. Okay. All right, does your notes have percent increase and percent decrease on them? On the below this? All right, well, let me just go ahead and show you. It may be somewhere else, but I know you need it. So let me just go ahead and put it on here. Percent increase or decrease is easy. If they're asking you how much something's going up or down, you use this formula. Original amount minus new amount over original amount. So let's just do one. All right, what's something that's increased in, let's do gas prices. All right, so let's say that gas prices went from, I don't know, $1.61 to $1.89. and you want the percent increase. All right. So all we're going to do is we're going to subtract those two and then divide by the 1 that we started with. Okay? All right, so I'm going to say 161 minus 189. And I might need to throw some absolute value in there because that's going to come out to be negative. Maybe I did that backwards. I did that backwards. I did this backwards, y'all. Switch it. Because percent decrease, I'm going to want it to be negative. So that's when it's going to, yeah, I did it backwards. Did you see how I noticed when I subtract these two, I'm going to get a negative number, but I'm looking for a percent increase. So that made my brain say, you just did something backwards. So if you run into the same thing and have a mental malfunction. All right, so let's go ahead and subtract it. Minus 1.61, so that's what, 0.28. So you just find the difference and divide it. And I got 0.173913. And there's more than that, but just write that for right now because there's something else I want to tell you. Okay. All right. If it says round to the hundreds, and this is tricky, so it's just a little confusing. If it says round to the hundreds, I don't need to round to the hundreds yet, because right now it's not a percent. So change it to a percent first, then round it to the hundreds. And I think that's tricky because a lot of people like round it to the hundreds, boom, and they round it, and then they move it to a percent. And it's not wrong. It's just not 100% right. I mean, you're in the right ballpark. All right, so that would be 17.39% because you round to the hundreds after you make it a percentage. I just think that's a little tricky. It doesn't get a lot of people, but it does get some people. So I just wanted you to see that. So a 17.39% increase. All right, you ready for 8-2? Okay. Everybody got that, or do I need to wait a minute? Y'all good? Okay, so again, 8-1 and 8-2 are just our tiny kind of review information. Then when I see you Wednesday, we're buying a house. And then next week, we're doing taxes. 4 sections, yeah, 4 sections. So these 2 are really fast. We do them in a day. But the other 2 are kind of slow. So it takes us like 3 days to do those. Okay. Okay. So actually, guys, so that was 8-1. 8-2 is taxes, and I save it for last because that's the one that is the most taxing on your brain, pun intended. No, really, I didn't mean to do that, but I heard it. So we're skipping 8-2. We're going to 8-3. So it's going to go 8-1, 8-3, 8-4, 8-2. Okay, just putting 8-2 at the end because you want that one last, trust me. Okay. It's not bad, but it's thought-provoking. Okay. All right, so simple interest. Simple interest is not where we live. We lived in a world of compound interest. We talked about that a little bit ago. When you buy a house, compound interest, car, compound interest, boat, compound interest. If you are putting money in the bank in a savings account or a CD or a money market, it's compound interest, and it's compounded most of the time monthly. But it could be compounded daily or yearly or weekly or quarterly or semi-annually. Most things are monthly that you deal with in everyday life. All right, now this is simple interest. Simple interest is just charged once. So it's not charged every month. It's just charged once in the life of the loan. And so you can imagine that simple interest is going to be way lower than compounded interest over a long period of time. But if it's a short period of time, simple interest might be better. And when it's a short period of time, that's when simple interest might work. That's why I said if you're dealing with a loan shark or a pawn shop, or, Aunt Gertrude, you might have a simple interest loan if you were dealing with one of those situations. Now, on the Little House on the Prairie days, probably they dealt more with simple interest, but I don't know. It could have been compound interest even then. I did look it up once to see when compound interest, got popular, and it was a lot longer ago than I expected it to be. But I didn't write it down and I don't remember. It was in the 1800s. But that's all I remember. I don't remember beginning or end. Okay. So if you're doing simple interest, you've got two formulas. This is the formula for interest only. Let me go ahead and give you both formulas. Interest only. All right. Your loan amount plus your interest is this formula. Okay, so there's the two simple interest formulas. If you only want the interest, you can do just the PRT. If you want the loan amount plus the interest, then that's it. All right. So you have to be careful with what they're asking you for. I don't really think that many people miss this because the math is hard, but I do have people, it'll say, what's the final amount of the loan? And they will just put what the interest is. So like you'll borrow $5,000 and you'll pay back $500. That's not logical, right? Nobody's that good to you. Okay, so let's take a look. This one only wants the interest. It only wants to know how much interest is being paid. So you're going to say the principal times the interest rate as a decimal times the time in years. It'd be $1,200? Okay. So $1,200 in interest. So you borrowed $2,000, you're paying $1,200 in interest. That's not a lot of money, but you're borrowing it for way too long, right? 10 years for $2,000. I mean, please stop eating out. Pay that money back. All right, so total paid back would be $3,200. All right, so one of the things that we do in our mortgage project is I let you look and see and compare the differences in financing it for 15 years and 30 years, because it's something that you really need to see. Okay, now look at this next one. This next one is tricky, so I'm going to do it in red. All right, now this only wants interest, but here's the problem. How long are we borrowing the money for the baseball uniforms? 9 months. But time must be in years. So, how many months are in a year?
12.
So all you have to do is say 9/12 of a year. And then your calculator does the heavy lifting. So it's not a big deal if it's in months. All right, so you've got 5,000 times 0.12 times 9 divided by 12, $450 in interest. So if we have to pay, once we pay it back, we'll pay back a total of $54.50. All right, the last thing I need to show you, and I won't be showing it to you a lot because, you know, it's getting, well, wait a minute. No, we're good. I was thinking we were a different class. We good? Okay, so this is the future value formula. This is this one. Oops, just kidding. That's your principal. Plus PRT, which is your interest. So we're good on time. We're finished early, it looks like. And this would be your ending amount. I'll give you a second. All right, let's go back to that time in years for just a minute. Let me just make sure that I have you solid on that. Okay, so this is, they gave you 9 months. I told you it has to be in terms of a year, so we did 9 out of 12 because there are 12 months in a year. What if it were, how many weeks are in a year? Yeah, I wasn't sure if everybody would know, so that's fine. There's 52 weeks in a year. So if there's 52 weeks in a year and you're compounding it for, I don't know, 10 weeks, you would do 10 over 52, okay? So it's like that. No matter what they give you, you can just, how many of those are there in a year? All right, so if it were days, if they were compounding it for 30 days, that one's a little bit odd because how many days are in a year? 365, but they don't use 365. They will divide it by 360, and that's called banker's daily. And we all know bankers take a lot more than 5 days off a year, so I don't know exactly where that number comes from, but that's the number they use for computation. But my lab will tell you that, so you don't have to memorize that. They'll just say it. But when you see 360, know that when your brain says, I thought there were 365 days in a year, you were right. Okay, that's banker's daily. Okay. All right. So let's go ahead and do this one. So here is your final amount, or sometimes that's referred to very often on my math lab is the future value. How much at the end? Now take a look. Can y'all tell that this is the same formula? All right, what I did, there's a P here and a P here. So what I did was reverse distributive property and pulled it out. But if you distribute it, P times 1 is P and P times RT is PRT, you can use this formula either way you want to. This is me being lazy, okay? But it's the same formula. Same formula. So use it either way you want to, okay? All right, so if you want the future value, that means they want you to find A. So I'm going to say A equals the principal plus the principal times the rate times the time in years. I'm doing this version right now. You already punched it in?
Yes, sir.
It's 4,600? Okay, thanks. All right. It's not 4,600, maybe.
You'll get 26 out of it, but I don't know.
No, I typed in 200, so I could be totally lying. 2,600. Okay. No, okay, so you add a little bit too much to it.
You should 2600 better.
Yeah, because when you punch this into the calculator, that's the principal plus the interest.
Oh,
And you did the principal, and then you thought and added, you were thinking just the interest, and then you added principal back in again. Okay, so we're good. All right, so if this is the starting amount of the loan, and this is how much you paid back, or how much interest did you pay? Right. It's easy, right? I want you to say yes. All right, so what if we're missing the rate or the time and we have to figure that out? Let me show you that. So let me crank it up a little bit. I want to show you if we're missing the rate and if we're missing the time or just different things, and then we'll call it a day. So go down to this one. What was my rate? Okay, no, I'm sorry. No, that's what we're fixing to do. But thank y'all. Okay, all right, here we go. So let's go ahead. This time we've got an A, we've got a P, we've got a T, but we don't have an R. So let's fill in the formula. So A equals P plus P R T. Let's plug it in. So 1820 equals 1700 plus 1700. We don't know the rate. And what do I put in for time? Because it says 6 months. 6 over 12. That was so fast. Everybody didn't have time to think. But good. That's good. All right. So there we go. So now we're just going to work this out just like we did in chapter 6. So first of all, let me simplify that a bit. What is, let's see. So that's 1,700 times 6/12, which would be half, but so that would be 850 R. And now it's just a two-step equation. I just multiplied these. That's how I got the 850. Because this is times, times, times. So I'm just multiplying the two numbers and leaving the R. Y'all good? All right, so what am I going to do next solving this thing? Sad math. We're solving. So sad math. First, we get rid of anything subtracted or added. Yeah. So let's move that 1,700 before we divide by the 1,850. So I'm going to move it across. What happens to it when I move it across the equals? Okay. So let's see. What's that going to be? 120. Now anything multiplied or divided. And that looks like it's going to make us a good rate. So 120 divided by 850. Make sure you go enough decimal places so that you can round once they tell you to. And this says round to the nearest 10th. So 14.1%. I'll leave that there a minute. Well, I mean, it's definitely got some stuff to do with it. It gets deep. Okay. What do you think? You got it? Does it make sense? It's really just putting chapter 6 with percent. All right, so one more. The only thing that I guess we haven't done, well, we'll go ahead and do this one. the pawn shop. Okay, so, because it's word problemy. All right, we take a mountain bike to the pawn shop. You know, we just bought that mountain bike, dang it. Now we're taking it to the pawn shop because probably we should have gotten groceries or paid the power bill. I'm not sure. He is going to loan us $552. 1 month later, we get the bike back, but how much did we pay him? 1 month later. Pawn shop / loan shark. Okay, so let's look at our interest rate here. So what is my A? It's the 851. It's the ending amount. I'll highlight what we know. All right, so the 851 equals 552 plus 552 times the rate that we don't know times my time. What's my time? 112. If it's in years already, it's not tricky. Okay, so I've got 851 equals 552 plus 552 times 112, which is 46. And then we're going to subtract that 552, divide by that 46, and it's 6.5. Does that mean 6.5%? We didn't move the decimal. It just turned up right there. It's 650%. But that feels like it should be 650%, right? Mm-hmm. Oh, that was 1 month. Yeah. Well, don't pawn stuff. I had a friend that I went to high school with, and she had a really nice engagement ring, and she would pawn that thing and pawn that thing and pawn that thing. She was a bit of a drug addict, but anyway, I don't know what happened to her, but this was post college. She got her college degree before she turned into a drug addict. Sweet girl. Just once you say yes, apparently it's hard to say no. So anyway, I mean, because she was great. She was smart. She had a degree, but anyway. All right, and then this is the only other thing that I wanted to mention to you. I noticed on your Chapter 9 test, most of y'all were solid in rounding, but I have a handful of you that are a little bit iffy, so I just wanted to make sure that I covered that. If it says round to the nearest cent, that would be the hundredths place, right? Okay, and y'all know the rule. If it's 4 or more, so here's the hundredths place. So we look at this one. If that one's 5 or higher, we go up, right? All right, and if it's 4 or lower, it stays the same. It doesn't go down, it stays the same. All right, so that's just regular rounding rules, but there is something in this chapter that will make you cuss. So let me tell you now so that I can save you some profanities, okay? All right. When you're doing my math lab and you're working these problems and it tells you you're wrong and you know you're right, let me tell you what it's going to be in the directions. If your directions, now this just says round to the nearest cent, right? What does this say? Round up. But the up is not even jumping out at you unless somebody calls your attention to it. Round up means round up no matter what, okay? All right, so let me write that down. Round up means go up for everything. So regular rounding rules don't apply. So if you had 3402.5, that would tell you go up. If you had 34.024, that would tell you go up. Up, you round up no matter what, okay? So look for that up to save yourself a little frustration. I wish they would make it like bold or something, so that it would at least catch your attention, but it is there. 2 sections done early. Go on. All right, y'all have a great day. Bye, y'all. Unless you got questions, I'll see you later.